Well, thank you very much for inviting me to present at testing stage. And I'm going to talk about a holistic approach to testing and continuous delivery. And the material in this presentation is from a lot of different people that we've been working together on this over the years. So I hope you will enjoy. So, a little bit about me. I have been lucky to work on a lot of small cross-functional teams where we all pitched in on activities all around the continuous DevOps loop. And I've been a hands-on tester on agile teams for more than 20 years. And have also been lucky to collaborate with Janet Gregory to write books and video courses. And we also have our training company and our courses on holistic testing. Um, so I've been very interested in continuous delivery for really my whole career, but really getting into the last 10 years of how the technology has helped us advance those practices. And feel free to get in touch with me anytime if you have questions after this conference. Just email me, or you can get to me on Twitter or LinkedIn. So I'd like to share some experiences I've had with my teams and how I found that we can use this a holistic approach to learn how to build quality into our product so that we can succeed at delivering small changes to production frequently at a sustainable pace. So we're not stressing every time we deploy to production. It's just a nice, steady cadence. So I'm sure that a lot of you, if you've been working on software teams, have seen problems. The feedback is too slow. You release something you run your continuous integration with your automated tests, and maybe they fail and you don't get the feedback that you need. You have regression failures in production. You change one thing in the code and it totally breaks something else that you didn't expect it to break. And of course, because of pressure to deliver and deadlines, a lot of teams acquire a lot of technical debt and testing debt. So they fall behind on test automation. They don't use good practices in their coding, and everything just keeps going slower and slower. So I'll just share one story. One of the teams I worked with, I do think you learn more from failure than success. So it's good to fail sometimes. But I was on a team that was we considered ourselves a pretty high performing team. We were embracing the extreme programming practices. We did pair programming, test driven development, continuous integration. So every time we made a change, it kicked off a build, ran our automated tests at every level, and could automatically deploy to a test environment. So we had thousands of automated regression tests at the unit level, the API level, the UI level. It was a web application. It was actually a project tracking tool as a web application. And we had what we thought were good deployment pipelines. Our application was hosted in the cloud. We had a blue-green deploy so that if we had to roll something back from production, we could do so very quickly. But we had about 30 developers, designers, people that weren't testers, and only 2 testers. So that was not a good ratio. And we still had some tests that could not be automated for various reasons. So we still had a manual regression checklist to go through. And what happened was our managers decided, instead of deploying to production every 2 weeks, let's deploy twice a week, which is quite a dramatic change. And we were not really that good at deploying every 2 weeks. Um, and so when we're doing twice a week, we would go through this manual regression checklist. And usually the things on the checklist work, but we would notice something else. And so that sent us down a sidetrack. We can't release. We have to figure out what this is. Do we already have this bug in production? It took a lot of time. And what happened was that the testers no longer had time to do exploratory testing, that human-centric testing that involves critical thinking to see if we have any unexpected impacts from the changes that we've made. to see if customers might use our features in a way we weren't expecting and cause problems. So this this turned out to be a big mess. And I'm going to share some things with you that helped our team actually solve these problems and be able to release twice a week and move towards continuous delivery. So I'd like you to stop for just a minute and think about yourselves. Um, if your team is trying to move towards delivering to production more frequently, or even continuous delivery where you could do it every day, um, and you're not able to get there, what's holding you back? What are the things that are getting in your way? So it's really important to identify the specific problems. In the story I'm telling, one of the main problem was the lack of exploratory testing, so that we would put changes in production and terrible things that we didn't expect to happen would happen, and we would have to roll back. Or we wouldn't be able to release at all because something happened that we didn't expected. Excuse me, it's early morning here. So just think about that as we go forward here. What are your problems? What solutions might you be looking for? So how did my team turn around this mess with trying to move towards more frequent deploys? Well, we reflected on the problem together, and we all agreed about the problem being the lack of exploratory testing, and that depending on two testers to do that exploratory testing, that wasn't going to scale. And the first thing we did actually was to just dump that manual regression checklist that I talked about. Nobody wanted to do it. Uh, it really wasn't adding a lot of value, and it was nothing in that list was breaking. So um, so that gave us more time, and then the managers asked us testers to teach the non-testers on the team, the developers, the product owner, the designers, everybody actually, some exploratory testing skills. So we started having workshops for them. We started pairing with them as they were working on production code, working on user stories. And what ended up happening is they really enjoyed exploratory testing. It became part of the skills that the developers needed to advance in their career. So it was part of their skills matrix that they needed to get good at, which motivated them. And so the developers took over responsibility for exploratory testing at the user story level. So before they made a pull request and said, we're done with this story, we think, they needed to go through a little checklist themselves of let's explore do some of this manual exploratory testing just to be sure. And then we testers could write exploratory testing charters at the feature level, and we could pair with other people on the team to do those charters once enough stories were done in a feature. So it just took this whole team collaboration to learn those skills. So whatever your problem is, it's going to take everybody on the team pitching in, collaborating, learning together. So one really good way to do this is using the holistic testing model. This is something that actually Janet came up with a couple years ago. Um, thinking about, hopefully you're familiar with the infinite DevOps loop. If you go out to Google a DevOps loop, you'll see that the ones that come up have a testing phase in them, which is not good because we have testing activities throughout the software development lifecycle. So the holistic testing model is a tool to help us think about that together with our team. What are we going to have to do at these various stages? And I'll go into a little bit of detail about some of these stages. But the idea behind this is these are stages. There's no set time for how long you spend in a stage, and you would pause between each stage to think about if you're ready to move on. And you're also often going to iterate back. You might get to the build stage and start writing production code and realize, oops, there's something we didn't understand, or there's something that's too hard to implement technically, we need to go back and rethink this. So maybe we need to go back to the planning stage, or even maybe we realize it's not the right solution to customer problems. We go all the way back to the discover stage. So the idea is you continuously doing these things and everybody's involved throughout the loop, regardless of their specialty on the team. We're not going to throw the code over to operations to deploy and release it. We're going to work together with operations if we have a separate operations group to do that together. We build the code, we own the code. It's kind of the motto of DevOps. So the first thing that we do when we're writing software is think about what are the ideas, what feature do we want to build next? And the business stakeholders, the designers, the product people, they come with these ideas, they think about it, and they may hopefully involve people from the delivery team to talk through those ideas, um, and just kind of test the ideas, see if they seem like things that will give value to the customer. And then we start looking at what are the risks that might be involved. So in the planning stage, we may do something like a risk assessment or a risk storming. And Janet and I have found that using visuals really helps teams with this, especially in our virtual world, so many people working remotely. We can use online whiteboards like Miro and Mural and Google Docs to do this together, have virtual sticky notes, draw together, brainstorm together. Helps you think outside the box. Test our assumptions. Things like impact mapping, story mapping, to start dividing our feature into stories that are small enough to be done in a couple days, that are testable. So this is what we do in the planning stage. And so we're testing before we've even written any code. So now we're seeking to understand at a deeper level. So we've got a high level understanding of the feature. We've split it into stories. And now at the story level, we're going to try to dive a little deeper. So this is where practices like acceptance test driven development and behavior driven development really come in. Things like example mapping to help the business stakeholders and the product owner or product manager explain here's the business rules for each business role. Here are some concrete examples of how this piece of this feature should behave. When the user does this action, then this other thing should happen. So that we really build a shared understanding across everybody on the delivery team as well as everybody on the business side. We might include platform engineers or site reliability engineers in that discussion, because we also want to think about when we get this out into production, what data will we need to know that it's behaving properly, and how will we see if our customers are having problems? If they have problems, how will we know what the problem is so we can fix it? So we're doing a lot of things in this stage. And again, this is all things you're doing before you've actually started writing the code. Our goal here, and this is kind of the agile testing mindset, we're trying to prevent defects from getting into the code. We're trying to build quality in so that we can feel confident to deploy and release to production frequently. Now, we're going to start actually writing tests and code, this thing we do together because it's all part of software development. And again, we're going to, in the case of the team I was talking about, we're going to start doing exploratory testing at the story level as we're building these stories. And then again, as we get more stories ready for a feature, we'll do story levels, exploratory testing at that higher level. And of course, lots of other testing activities. We might do security testing, accessibility testing, things like load testing are going to come a little bit later in the loop. So we're going to automate our tests. We're going to actually instrument our code so that we can see what's happening in production. And again, it's a collaborative thing. One of the practices that we recommend to people if their culture is more people working solo is for a developer working on a story, before they think they're done, get together with a tester or somebody else and just go through what they've done. Here's the story. Here's the code we've written. Here are the unit level tests we've written to support that. Let's do a little manual testing to see if it's behaving like we expect. And that just takes a few minutes. It really improves communication in the team, and you're going to, like as not, you're going to spot some problems that need to be fixed before you've even done a commit to the code base. Now we're moving on to the right side of that loop, and we've written the code. We do continuous integration. We build an artifact that we can deploy to a development environment, to a test environment, and the reason we separated deployment out on the model is because the deployment pipeline is so key. It's so important to have a robust deployment pipeline that runs quickly, gives you the fast feedback from your automated tests and other activities that check your code correctness, and is reliable. Your tests are reliable. That's really critical if you're trying to move to continuous delivery. You can't do without that. And it may not happen overnight. You may start with a lot of things not automated yet, but just keep moving to get the fastest deployment pipeline that you can. And of course, not everything can be automated. So things like exploratory testing, accessibility testing, user acceptance testing, those have to be built into your workflow to production as well, even though they're not automated in the pipeline. So it's really important for teams to visualize that path to production, what all has to happen, how can we do it in the most efficient way so that we can deploy frequently and get fast feedback. So yeah, and this is where we can start doing testing quality attributes besides functionality, such as performance, reliability, do more security testing, just all those abilities, portability, all the things that are depending on your context can be important. So it's important to identify which quality attributes are important and make sure that we test those at the right time. Okay, my slide doesn't want to advance. There we go. Now, now we've turned the features on in production. If we're doing continuous delivery, we're using some kind of release strategy to hide features, hide new changes from customers until we feel confident that they're ready to go, or till we've finished testing and finished building them. So once they're in front of our customers, and maybe they're only in front of some of our customers, we're doing some kind of graduated rollout or canary release. We want to see what customers are doing and how the software is behaving. So we look at our dashboards, we look at our log files, we look at our alerts, our analytics, and this helps us spot problems and respond quickly to problems. And it also helps us learn how the customers are using our product. Maybe we released a new feature and they're not even using it. I've had that happen. So what does that mean? Do we need to make some changes? We need to go talk to some users and see what's going on. Maybe a lot of errors are happening and we're going to see that in our dashboards. Or maybe somebody calls in with a problem, we don't even see it, we didn't get an alert for it. We have the data, we have the events that we can go ask questions of that production system and understand what's happening. Some of you may have heard the term observability, and basically my favorite definition of that is when there's a problem in production, you can go get all the data you need to analyze that problem and understand it so you can fix it without having to add logging or instrumentation to the code and redeploy to production. So it's really key to be able to respond quickly to gather all that data. And again, that's done in your planning stage. What data are you going to capture to understand how each feature is behaving? And from this data, we can learn. We can create hypotheses. We think we can cut down on the number of 500 errors if we do this, or we think more users will use this feature if we make this change. So we start doing these small experiments. And again, These are things that everybody on the delivery team can add value to. Designers can add value, business analysts can add value, product people can add value, marketing people can add value. People can take this data and work together to think how to improve the product, how to achieve our quality goals, how to achieve our goals for customers. So, summing it up, the left side is all about preventing defects in the code. The right side, we may find some defects we missed. We're going to fix them as quickly as possible. We're going to get feedback on how our product is being used in production so that we can continually improve it. No matter what your specialty or role is on the team, think about what stages you're involved in now. How can your team collaborate more all the way around this loop? And that's what the holistic testing model is about. There's no one testing activity that's most important. They're all important. And having a diversity of skills and experience and backgrounds working on those problems, we're going to be the most innovative and be able to fix problems the most uh, faster than otherwise. Think about the relationships you could build. Who could you, as a tester, when I started a new job, I would always make friends with the operations specialists, people on the platform team, site reliability engineers. Hopefully it's a good DevOps culture where you have an SRE embedded on your team. But I would just make friends with people and say, "Oh, can I have a one-on-one with you every couple weeks for 30 minutes?" Or, "Oh, can you come and show us testers how the deployment pipeline, can you draw the deployment pipeline for us? Or can you draw the system architecture for us so we understand it better?" So helping each other is a good way to build relationships and collaborate. And I would encourage everybody to do that. That's really necessary to be successful with continuous delivery. So get everybody working together, no matter the specialty. Okay, another, I mentioned using the visuals in the planning stage to understand the features and divide them into stories. All kinds of things visuals help with. So let's look at a few of those. I mentioned asking your operations specialist to draw your pipeline. Getting your whole team together to understand the path to production for each change that you make in the code is so important, because until you understand it, you can't make it better. This is an example of a pipeline for teams doing continuous deployment, because any change they make, if it passes all the tests and gets through the pipeline with no problems, it's going to automatically deploy to production. Well, there may be some other testing we need to do, uh, that we need human-centric testing, manual testing, like exploratory testing or user acceptance testing. That's where the release strategies come in. Blue-green deploys, feature toggles, feature flags, canary releases, all those release strategies to hide features until we're confident to turn them on for all our customers. So um, I really highly recommend that you get as many people as you can together on your team and do this exercise to visualize your pipeline and spot places where maybe you can parallelize the tests, or do something to get faster feedback. Automated test suites, that's a big problem for most teams. A lot of us have flaky tests. Um, you know, do you have confidence in the automated tests that you have, whether it's a regression test, performance test, whatever it is? My team had a ton of, thousands of automated tests, and yet we were having regression failures in production. And once we started looking hard at those tests, they didn't provide good test coverage. I actually saw UI level tests that had no asserts. That's not really very helpful. So we really have to think about what we have in place for automation. And one good way to do that is this test suite canvas. And this is from Ashley Hunsberger. And look at one of your automated test suites. Maybe you have an API test suite, and ask yourself these questions. Why, what's the purpose of the test? What dependencies do we have? What constraints do we have? Is it running in a pipeline? What data do we use? when the test fails, who responds to that failure and looks into the problem and makes sure it gets fixed? How maintainable are those tests? Are they giving us confidence? Are they effective? So some of my favorite test canvas questions: what information does this test suite provide? To whom and how? And you can ask these questions when you're thinking about what automated tests you need and don't have yet. Um, do you pair on test automation, or do you do code reviews? Because some automation code could be, really need the same attention as our production code does. And remember, these automated tests provide living documentation. So it's very important that they're understandable, maintainable, reliable. And if you can't get the team to do these things together, do it yourself and then bring these questions to your team. All right. Okay. And I mentioned about my team having poor automated test coverage. So what we did was start thinking about what are the risks in the user interface of our application. So we got a cross section of the team together in a room: testers, developers, architects, product owner, customer support, and had one of the senior developers draw the architecture of the front end on a whiteboard. You could do this on a virtual whiteboard too. And we started marking the most high risk, what would have the highest impact if there were problems with it. And this took about an hour, but it was really valuable information. And then we started prioritizing, and now we could go back to our automated tests. And as we started working on new features, we could prioritize what tests to automate. And we also made decisions like, okay, we're going to use a different automation framework that we think will help us design better automated tests that provide more coverage. It just started us down a road of refactoring our existing tests and writing new tests in a really good way, especially at the UI level. And again, having this diversity of viewpoints, working on it together really was key. For example, the customer support people really knew the pain points that customers were experiencing. So this is a great activity to do, and do it with a virtual whiteboard as well. Lots of ways to talk about risk storming, mind maps, just anything that helps you brainstorm. You need to get out of your normal mindset and think outside the box. And these visuals, these techniques help you. You also need to focus. You can't fix everything. So you have to identify just a few things that are the most important that you want to focus on to improve. So maybe you do a lot of risk analysis, but it's not like you're going to know everything. There's always going to be something happen that you didn't expect. So what does your team do about that? What if something happens to the database while your application is running, or you have an external service that you use and you're accessing it with an API and suddenly it's returning errors? That's not something that you can necessarily expect because you have dependencies. So what do you do about that? I mentioned observability, um, and this is a way that you get visibility into your production system. It's kind of, think about it as instrumentation on airplanes. You need to find out, you might be flying an airplane in the clouds. You still need to be able to see. So you need to have data that helps you understand it. So this was something that my team learned about just at the point, because it was a few years ago, just at the point where we were having all these problems trying to move to continuous delivery. And so we were already using some analytics tools, Mixpanel. We were using Splunk and New Relic, and we had started using Datadog. Observability was really new. We didn't have the observability tools yet, like Lighthouse and Honeycomb, that are available now, that are awesome. But it's just started making us think about data and really focusing on gathering the data that we needed so that we could understand when we had problems in production. It was just a big wake-up call for us. And so the idea is we do all the testing that we can do, but our test environments don't necessarily look like production. We don't know everything customers will do. And we can monitor, but we can only monitor the things we expect to happen and set up an alert, put something on a dashboard. So all the rest has to be, we gather all the data we can in case we need it. So quality is a whole team responsibility. So that's the other part of holistic. Holistic through the whole software development lifecycle and holistic with the whole team working together. It's really important that you talk about what does quality mean for us. Is it a certain net promoter score from customer surveys? Is it 99.999% availability? Is it no defects getting to production? Have those conversations, set your quality goals, commit to getting to them because it's going to be hard. You're going to have obstacles. You're going to say, oh, we're going to always do acceptance test driven development, and then find out that it's hard to do that with the code you're working with. You have to find a way to do it. And having this, again, having the diversity really helps. I think it helps us. We all have unconscious biases that kind of cloud our vision. And I think that that helps us get over that because I'm hoping we all have different unconscious biases. So if I'm testing and looking at something, maybe there's a problem in the user interface and I don't see it, but I'm pairing with somebody and they notice it. So working in pairs, working in ensembles is really, really important. So back to my team, we're trying to get with continuous delivery. Sometimes the developers were developing new features that involved things that they had not faced before, and they were difficult problems to solve. Like, what algorithm do we need here? What heuristic do we need here? So we started experimenting with mob programming or ensemble programming, and I had a little bit of experience with that, so I started facilitating sessions to do that. We also, for testing, so we would get a group of, we would just say, hey, we're going to spend the 30 minutes or an hour testing this new feature before we put it in beta. And we would write exploratory testing charters and have people pair up and work together. But we would all get together in a room or a virtual room so that we could say, hey, has anybody noticed this problem? Or, oh, Lisa, you move this while I do that, and see what happens. So we could collaborate on that. And it was so effective because we found so many issues really fast, or we didn't find issues and we got really confident. Now, sometimes we would just do ad hoc testing, like let's all just bang on it and try to pretend we're real users or use personas. A lot of techniques that we use, but that was very effective. We also use this for acceptance testing at the story level. So when we had several stories for a feature ready to go, we'd spend 30 minutes, get the product owner, the developers, a tester, a customer support person, a designer in the room, do the acceptance testing together. If there was a question like, I don't think that this button is in the right place on the screen, or I don't think this validation is correct, the person who can answer that question was in the room. So it saved us so much time and it was so much effective. So collaborating together really sped us up and made us more able to do that twice weekly delivery. So, we're people, we're humans. And I've talked a lot about building relationships, and it's so important. There's a book, Katrina Clokey has a book called A Practical Guide to Testing in DevOps, and it's available on LeanPub. I highly recommend it. But the first section of the book is all about building relationships. People within your team, people outside of your team, depending on how your organization is set up, because we do need to collaborate. So think of the people in operations, customer support, the business departments, finance, all kinds of people are important, and they can help you understand the business domain. They can help you understand the customers. They can help you achieve goals. Maybe you need the finance department to budget more money so that you can adopt a new cloud technology or something like that. So this is something that really helped us working together. We actually were a cross-functional team. We did our own operations right on the team, so it was more of a true DevOps culture. But when I've had separate departments, just getting to know those people, and I found they were happy to pair with me. And oh, we're going to go to a new tool to do our deployment pipeline. We could work together and think about the risks of moving to that tool and how will we do testing to make sure it's okay, come up with a test strategy. So lots of collaboration potential there. And asking for help. People want to help. So don't be shy to ask for help. Now we know that psychological safety is a prerequisite for successful software development. Um, People need to feel safe to do experiments because they might fail. People need to be safe to ask questions, to call out potential issues. And if you don't have that, it's really hard to make progress. And some people think, oh, that's just never going to happen because there's so many cultures that are dysfunctional. But use your influence, try to get there. We do need leaders. If you're in a management position, use your leadership ability. Have a vision of where people need to be, and have the focus on quality, not speed. If you focus on speed, you're going to take shortcuts. You're going to, oh, let's automate those tests later. Let's do that testing later. Don't worry about it right now. Um, we'll refactor the code later. Whatever it is, that's just going to build up technical debt and slow you down. Learn the good practices that are going to help you build quality into your code, like continuous integration, pair programming, test-driven development, test automation, uh, and learn those practices. It takes time. Invest the time to learn them, and then you're going to go faster. And again, this needs a vision from leadership that they understand. They need to make an investment in quality. It's really going to pay off, but you need to take a more long-term view. I really highly recommend this book, Continuous Delivery. There are a lot of other good books as well. But this is really the principles of continuous delivery from this book are so important. And using these principles to guide your work, it's going to always lead you in a good direction. So whatever the problem is, you don't know how to solve it, go back to the principles and think about how to apply that. And this book came out in 2009 or 10. Our team was actually doing continuous delivery, but we didn't have a word for it yet. So when I read this book, it's basically a book about testing. It was really, really helpful, and I go back to it a lot. So very important. Use frequent retrospectives. I say at least once a week. Or if you've had a big problem, you want to retrospect on it. Identify the biggest problem in your way, and then design those small experiments to make it less bad. Maybe we have a really long cycle time because the product owner keeps rejecting our stories. We think we understand what to build. We deliver to the product owner, and they say, the team I've been talking about in my stories here, we had a really high rejection rate and a really long cycle time or lead time to get those stories out to production. And so we tried a technique called example mapping from Matt Wynn. So in our pre-iteration planning meetings, we got a small cross-section of the team there, went through each story with a product owner and understood the goal of the story, what's valuable to the customer or the business here, give us each of the business rules, give us concrete examples to illustrate those business rules. And that helped us all get on the same page so that when we had our iteration planning, we had all this information and we could use those examples to turn into test guide development. And lo and behold, within a couple weeks, it cut our rejection rate down by 50% and sped up our cycle time. So it might not have worked. If it didn't work, we would have tried something else. Small experiments. So again, get your team together and talk about quality. What is it? What does it mean to you? And how can we use this holistic testing approach to fit testing activities all the way around the DevOps loop for continuous delivery or continuous deployment? And how can we get everybody on the team and people outside of our team engage in building quality in engaging in those testing activities all the way along. So these are a few resources that you could go to for more information, and I will make these slides available. You can take a screenshot. There are lots and lots more. I actually have the next to last bullet point there. If you go to lisacrispin.com, you can find a whole page of books, videos, courses, blog posts, all kinds of resources to help you learn about continuous delivery and DevOps and observability and lots of other things. So I would highly recommend if you want to continue your learning journey, there are a lot of great resources there. If you have some great resources to add, please send them to me and I'll add them to that page. That's my attempt to share the information. So thank you very much. I wish you good luck in working all together and collaborating to succeed with continuous delivery using this holistic testing approach.